So if you could, you should have been done reading pages 50 and 51. If you could go ahead and talk to your partner, and remember when you go to talk, we want to use these ways to talk. Talk about things that so what did you mean by, it sounds like to me, or so what you said was, I disagree, agree. Go ahead, talk to your partner about 1 and 2 on the warm-up. Go. Then you should have got up and read them. Maya, go with Liam.
Since obviously 1 is just like half, and then half of 0.5 of that is 2 for the length, so it would be and
Okay, so if we look at this, first thing I did was I converted 150% because it's asking me to take this photo, which is 4 by 6, and I've kind of distorted it. It's not quite exactly looking right. But it's a 4 by 6 photo. And it says, make it 150% bigger. So the first thing I did is I converted 150% into 1.5. I take the decimal, I move it 2 places, and that equals 1.5. So then I took because this is now my scale factor. I multiply the scale factor by one side, I multiply it by the other side, and I get a new dimension of 6 by 9. So that is my new dimension for my picture, is a 6 by 9. Questions about 1? So 2, am I enlarging 2 or reducing 2? I'm reducing it. So this is being, I gotta be careful here. Oh, come on. I'll do it up here. It's not drawing down low. Don't know why. This is reducing by 2 by 3 from a 4 by 6. So this is what this means. It's basically saying if I take 4 and I multiply it by some scale factor, that's what we have to figure out. So what's the scale factor? I'm going to get a side length of 2. And then if I take 6 and I multiply it by some factor, I'm going to get a side length of 3. So what do I multiply by 4 to get 2? 0.5, or half, right? Now, does 0.5 scale factor make sense if I'm going from a bigger picture to a smaller picture? Yes. Yeah. Because any number less than 1 but greater than 0 is going to make my photo get smaller. So if my scale factor is 0.5, it says what percent should I use? 50%. Because 0.5 as a percent equals 50%. So that would be my answer for number 2. Man, this thing's jumping all over the place. What's going on? Go ahead and talk to your partner about 3. But listen, 4 and 5 I want you to have a much deeper discussion about. Because we should have some differing answers here, possibly. Okay, go for it. 3 is easy, but 4 and 5 is a little bit deeper. Go.
Okay, so 3, I said they will be and then for number 4, the perimeter is 200% bigger than the smaller photo. Because if you multiply both the sides by 2 smaller,
So, here I've got number 3. All angles are the same because the new image is similar. How do I know it's similar? What did I do going from the bigger image to the smaller image? What did I use? A scale factor. And we know, guys, if you look back here, an object is going to be similar when you have corresponding sides. That means all sides are either increased or decreased by a scale factor. And that's exactly what we did, is we decreased this side by half and that side by half. So that means that the angles will not change. That is a similar figure. Number 4. How will the perimeter of the original photo compare to that of the smaller? You could have a couple different answers here. So here I said the original perimeter is 20 units. Smaller photo, well, that is 2 by 3. So 3 plus 3, 6. 2 plus 2, and 6 plus 4, 10. So I get a new perimeter of 10 units. Now, I could have got this a couple different ways. I could get it by adding up all the sides. Okay, I could get it by adding up all the sides. One way. The other way is I could take my old perimeter of 20 units and times it by my scale factor, which is 0.5. And what's 20 times a half? 10. So how does it compare, though? That's the question. Yes? Okay, so I could say, like Taylor just said, the original is twice as big. The original perimeter is twice as big. Let's think about how it would compare if I talked about the smaller photo. Yeah?
So, the perimeter of the newer photo is 50% the size.
Nice. Yeah. So this is going to be 2 times bigger, going from the original to the smaller. But if I said, hey, the smaller photo is 50% or half the size of the original photo. So I can say that either way. And one thing I want you to notice here, and I don't know if you've noticed it yet. I'm going to draw the 2 photos. So that's 4 by 6. This is 2 by 3. If I go this way, we have a scale factor of 2. Right? Small to big, scale factor 2. If I go this way, I have a scale factor of 1/2. Do you know what you call 2 and 1/2? Begins with an R. We've talked about it before, but it's been a while. A reciprocal. Jacob. Yeah. These are reciprocals. If I know the scale factor one way, I just take the reciprocal, and now I know the scale factor the other way. It's pretty cool. It works all the time. If this is 4 times bigger, if this is 4 times bigger going this way, it's 1/4 going the other way. Just the reciprocal. It's pretty neat. Okay, talk to your partner about the area, because this is what I want to... What'd you get? You already talked to him. What'd you get for area? Ben?
For which one?
It says, find the area of the original in smaller photos. How do these areas compare? So what's the area of the original photo? Yeah, because it's 6 times 4 equals 24. And then the new area is 2 times 3, which equals... So what do we notice about the area? Axel?
The area of the original photo is either 4 times bigger or 400%.
Yeah. So this one is 400% bigger than the new. Yes?
The new one is 1/4 the size of the original.
And the new one is 1/4. And again, think about that. What are those two numbers? Reciprocals. Right? I go one way because there's talking about scale factor. One way is 4 times, the other way is 1/4. Pretty cool. All right. Good work on this. So today, just want to remind you guys, check Infinite Campus. I've had a lot of kids, because we finally did progress monitoring, kids go, oh my gosh, I'm missing that. So today I've already picked up like 5 or 6 different items that were missing. And then go to Google Classroom, and then that will give you more information about exactly what it is you're missing. Infinite Campus will say what it is. Go to Google Classroom, and you can figure out how to do it. Today, this I can statement. It's pretty interesting. We're talking about quadrilaterals. What is a quadrilateral? Liam?
It's a shape of 4 sides.
Shape of 4 sides. Pretty basic. And then you read about reptiles. Talk to your partner about what a reptile is.
A reptile is a shape that you have multiple ones together. It creates a larger.
When you put it together, together it can't make another of the same bigger shape.
So a reptile is a shape that I can take, and I can use many of them to create the exact same shape, but much bigger. So I'm going to use not a quadrilateral, I'm going to use a triangle to show you how this works. So here's this triangle. I'm going to take this triangle and I'm going to tessellate it so it actually creates a bigger right triangle. So you can see that I started with 1. Okay, and what I did was I made a bigger right triangle. Now this is where the questions come in. This is what you're going to do today. Except you're doing it with quadrilaterals. You're going to have to answer what the scale factor is. You're going to have to answer how much bigger the perimeter is. And you're going to have to answer how much bigger the area is. So right now, talk to your partner about what do you think the scale factor is going from this to that? Go talk to your partner.
It would be 4 times bigger because they added like 3 more triangles. So like wait. So it wouldn't be 4 times because wait, are we talking about area or perimeter?
Mm-hmm. Scale factor.
Oh, so
How could you find the scale factor without
so wait, so for the perimeter it would be I think 2 times as big.
So David's got it. He's chewing on it. Love it. He's chewing on it. He's like, wait a minute. The scale factor can't be 4 because it looks like it, but he's like, wait a minute. This side didn't get 4 times bigger. How much bigger did that side get? 2 times. That's it. It was 1. Now it's 1, 2. And then this side didn't get 4 times bigger. It went from 1 to 2. And then this side went from 1 to 2. So what's the scale factor? 2. And then David was like, the perimeter is definitely twice as big. Here it was 1, then it's 2. Here it was 1, then it was 2. Here was 1, then it was 2. So he was like, it's definitely twice as big as the original. What about that? And how does that work? Riley?
So if the scale factor was 2 and the perimeter was 2, it'd be 2 squared, which would be 2 times 2.
So what Riley's saying is, says, hey, I know that the area of a similar object is going to be the scale factor squared. So this scale factor is 2. What is 2 squared? So if the scale factor was 3, how much bigger would the area be? What's 3 squared? 9. Ooh, I heard someone say 6. 6. Right? Because 3 squared equals 3 times 3. Not 3 times 2. So remember, that's very important. So that's what you're going to do today. You can literally set your paper up like I have mine. When you draw the tessellation or the reptile, that's A. When you answer these questions, that's B. And then there's one more part you're going to work on today, which is C. C is really cool, but you got to work hard on A and B. Quite a few kids got to C today, about half the class. So that is the I can statement. Is using quadrilaterals, four-sided figures to make these reptiles, making bigger ones. Now remember, I can't take a shape and then make something that doesn't look like it. I got to take that shape and make a bigger one. That's the challenge of a reptile. Any questions about this? It's a pretty fun activity. So today, you will need your template that you grabbed at the door. Which looks like this. You're going to need one of these. Okay. You will also need a white piece of paper. Just wait though. And then these are the quadrilaterals you're going to use. You're going to use a rhombus. Okay. You're going to use a rectangle, and you're going to use a, what's this? Trapezoid. So you're going to use those 3. So when I use the rhombus, I'm trying to make a bigger rhombus that has the exact scale factor. It has a scale factor. A rectangle, trying to make another rectangle, but bigger. And then this is the fun one. It's cool. All right. Any questions about this? So again, you're going to need your template and a piece of paper. Here they are. It's 3.1 and 52 AL, BL, CL. All right? Get going. Yeah, mine can move. Thanks for just waiting. Did you grab one of those, man?
No.
Okay.
So where is this sheet to work on?
Okay, hey, do you mind if I put the marker here and we record your voices?
No.
For the video? Is that okay?
Yeah, that's fine.
Okay. All right.
I just don't know what to do. Like, where is the sheet I need?
Hey, Kleckner, you grab a sheet from there. I thought I saw your jacket down there. You were wearing it.
That's my sister's jacket.
So you guys share something in common.
Ooh, I don't know.
No.
Alright.